In this video, we'll talk about how to find the holes in rational functions. So I have a couple examples for us to work through here. Let's check out the first one. We have x squared plus 2x minus 8 over x squared minus 6x plus 8. To find the hole of this rational function, we first have to factor the numerator and the denominator. So the way that we can factor the numerator is we have to ask ourselves, what numbers multiply to negative 8 but add to positive 2? Well, that would be 4 and negative 2. So we can factor the numerator as x plus 4 and x minus 2. And in the denominator, we can do something similar. Ask ourselves, what numbers multiply to 8 but add to negative 6? So that would be negative 4 and negative 2. So we can factor this as x minus 4 and x minus 2. Now notice that after we factor the numerator and the denominator, we're going to try to see if there are any terms that match in the numerator and denominator. And it turns out this x minus 2 occurs both in the numerator and the denominator. So we're going to cross that out. So those two are going to cancel each other out. And this whole thing simplifies to x plus 4 divided by x minus 4. So the hole in this graph will occur at the x value that makes this expression equal to 0. So if we set x minus 2 equal to 0 and we solve for x, we can add a 2 to each side, and we find that x is equal to 2. So there's a hole at the value x is equal to 2. Now we just need to find what's the y value that corresponds to this. Well, we can just plug this into our simplified expression of x plus 4 divided by x minus 4. So when we do that, we get 2 plus 4 over 2 minus 4. So 2 plus 4 is 6. 2 minus 4 is negative 2. So 6 divided by negative 2 is negative 3. So that's our y value. So the hole occurs at 2 comma negative 3. And if we were to graph this function using either a graphing calculator or some type of graphing software, what we would find is if we plot the points 2, negative 3, so let's do that. So 1, 2, 1, 2, 3, right about here. There would be a hole at this point. So actually, let's graph that as an open hole. And this particular function would look something like this, where it kind of goes down and it extends this way. And then on this side, it kind of extends like this, something like that. This isn't drawn to scale, but just know that this point right here, 2, negative 3, is where the hole will occur. All right, let's try one more example. Let's try to find the hole in this rational function. 2x plus 6 over x squared plus 5x plus 6. So remember, to find the hole, we first have to factor both the numerator and the denominator. So the numerator, it looks like we could pull out a 2 from both of these terms. So we'll have 2, and we'd be left with x plus 3, because 2 times 3 is 6. And the denominator, we have to ask ourselves, what numbers multiply to positive 6 and add to positive 5? Well, that would be 3 and 2. So we can factor this to be x plus 3 and x plus 2. Now we look for what terms are in both the numerator and the denominator. Well, an x plus 3 occurs, so we can cross those out, and we can simplify this whole expression to 2 over x plus 2. So just like in the previous example, the hole is going to occur at the x value that makes this expression equal to 0. So we had x plus 3 is the expression that occurred both in the numerator and denominator. So we can set that equal to 0 and solve for x. So to solve for x, we can subtract a 3 from the right-hand side, and we're left with x is equal to negative 3. So a hole occurs at x is equal to negative 3. To figure out the y value that corresponds to that, we just need to plug it into this simplified expression here. So if we plug in a negative 3, we get 2 over negative 3 plus 2. So that simplifies to negative 3 plus 2 is a negative 1. So 2 over negative 1, which is just negative 2. So that's the y value. So the hole occurs at the coordinate negative 3, negative 2. And what you'll find is if you use a graphing calculator or graphing software of some type to plot this, if we go 1, 2, 3, 1, 2, there will be a hole in the graph right here. And this particular graph is going to have the shape that looks something like this. The graph extends like this, and on this side it will extend something like this. But just know that the hole right here will occur at the coordinates negative 3, negative 2.